Hello all, I'm Ezzy. Today I'm going to talk about G-protein link signaling. To ease your understanding, here I provide you with a model called BE. As introduction, G-protein is also known as guanine nucleotide binding signaling, and it is heterodimer, consists of alpha, beta, and gamma subunits. When there is no molecule bind to G-protein coupled receptor, G-protein complex will be in inactivate form, which is it is in heterodimer, alpha, beta, and gamma subunit, and also GDP will bind to alpha subunit of G-protein. When there is a molecule come and bind to G-protein coupled receptor at its binding site, it will change the conformation of the G-protein coupled receptor and eventually will activate G-protein complex. What is meant by G-protein complex is inactivated form is where GDP replaced by GTP at its alpha subunit, and later beta and gamma subunit will move away from alpha subunit of G-protein. And then alpha and GTP will move to enzyme or protein. In this case is adenylyl cyclase. Upon the binding, adenylyl cyclase will facilitate the transformation of ATP into CAMP. CAMP is a secondary messenger that will relay the signal and also will amplify the signal downstream. Later, CAMP will bind to a protein. In this case is protein kinase A. So once protein kinase A is activated, it will trigger the downstream pathway. The cascading mechanism of secondary messenger will result in various effects such as increase of heart rate, dilation of skeletal muscle blood vessel, and also it will break down the glycogen into glucose.